Okay, so we've just learned that a redox reaction takes place between molecules or atoms where one of these substances gains electrons and one of them loses electrons. And so we remembered the oil rig, where oxidation is loss.
Yeah.
And reduction is gain, and that was the red bit. The reduction is gain.
Yeah.
Reduction is gain. So what we can do is we can then have an electrochemical cell where we have one of the substances in here, which is, we call this an electrolyte, meaning that that it supports the flow of charge.
Yeah.
And you have a salt bridge here, and this completes the circuit. Okay. So the way this would work is you have an anode and a cathode, and these one is positive and one is negative. Okay, so there is two types of cell. There's a galvanic and galvanic cell and an galvanic and a galvanic cell and electrolytic cell. Yeah. So the galvanic cell makes current, and an electrolytic cell. So a galvanic cell basically converts chemical energy into electric energy, whereas an electrolytic cell, that is one where it does the opposite. It takes electricity and converts it to chemical energy.
Yeah.
Okay. So now let's just use this. So the other rhyme you have to remember is red cat.
What does it stand for?
Reduction takes place at the cathode. Red cat.
Oh, okay.
So
red cat.
Yeah. So it's actually following on.
And isn't there oil rig?
Yeah, so the oil rig is what this was supposed to be rig. Pardon me. I was getting so oil rig or oxidation is lost, reduction is gain. And the other bit is red cat, which is kind of part of this red cat. Let me put it there. So instead of, let's do this. Let's erase this. Let's write our red reduction part of the rig, red. And let's write the cat there. Which means that this means that reduction takes place at the cathode.
Yeah.
Now, the other thing we have to remember is that, so one of these is a cathode, one is the anode. So the reduction is going to take place at the cathode. The other thing to remember in a galvanic cell, this is in a galvanic cell because the cells switch. So in a galvanic cell, which is what we're looking at here, your anode is negative. That's right. That's not good. So our cathode is positive, and our anode is negative. Now you must remember that in an electrolytic cell, this is switched. So in an electrolytic cell, it's the opposite. So don't be very careful. At some point, it's going to get confusing because if you learn that the cathode is always positive and the anode is always negative, you're going to get come unstuck when you get to electrolytic cells where it switches around. So that part is very confusing, and that was very confusing for me when I was in the trick.
Yeah.
So we've learned oil rig and we've learned red cat, and those are kind of standard. So oxidation is always loss, reduction is always gain, and reduction always takes place at the cathode, even if the cathode and the anode positive negative are switched. It doesn't, don't worry, reduction always takes place at the cathode.
Yeah.
So now what we can do is we know that you've got aluminium and we've got silver. Aluminium and we've got silver. Okay, Y is obviously a voltmeter because that's going to measure the voltage. Could also be the thing that measures the direction. Galvanometer. I think it's actually a galvanometer. Anyway, that's not that we can learn. I think it's probably a galvanometer, although we'll see. I think galvanometer because that will then measure the direction. Now, what I want to do is I don't know between aluminium and silver, Ag, which one is going to be reduced and which one is gained. And in order to say which is the anode or cathode, I need to know what's taking place at each of these. So I can go now to the half reaction table and I can look at aluminium and silver. So we see aluminium and silver. Ag is here.
Yeah.
And aluminium is probably lower. Down here, yeah.
Yeah.
So what do we know about the thing that's close to lithium? Lithium was always the thing that lost electrons, didn't it? Because lithium had one valence electron, it wanted to lose one to become like helium. So the aluminium is oxidized, right?
Yeah.
And if we, oh, okay, I just need to plug this in quick.
All good.
Okay, and if we understood better the thing at the top, okay, so we remember that fluorine is always reduced, right? It always gains electrons. We can see that the F2 plus 2 electrons goes to F minus, so it's gaining electrons. Does that make sense?
Yeah.
And it also makes sense because fluorine has those 7 valence electrons, so to gain 1 will be nice and easy for it. So whatever's closest to fluorine is the thing that gets reduced. And so we saw there silver being reduced. So silver's reduced here.
Yeah.
Yeah. So now that we know that, we can now go up to the top and we can have a look at the rest of this thing. Okay, so now we've got a lot of information. Well, from a red cat, we know that reduction is always at the cathode. So this is the cathode. And this is going to obviously be the anode. So let's actually write it in red. Cathode. This will be the anode. And with a galvanic cell, our anode is negative. It's sort of intuitive. Because if you anti something, you're negative. But that's not a good way to remember it, because we also know that the anode is positive in an electrolytic cell. It can be tricky.
Yeah.
Okay, so then aluminium, if it's oxidized, it loses electrons. So it's going to go to Al is going to go to then Al minus plus an electron. And Ag is going to gain electrons. So it's going to go Ag plus an electron is going to go to Ag.
Yeah.
So now we know that aluminium is the anode. Write down the overall cell reaction that takes place in the cell when it is working. Well, now we can put these together. So we can say Al plus Ag plus, we can actually say AgNO3. Because we can see that that's actually the thing. And we know NO3 is that's 6 minus, that could be 5 plus, yeah. And that's going to go to Ag plus Al NO3.
Yeah.
And if we wanted
So
to
basically swapping it around.
Yes, and if we wanted to write it without the NO3s, it would be this. So that's why we call the NO3 a spectator ion, because it's just kind of there, and it just it's not part of the
Is that the salt bridge, or is that different?
No, the salt bridge is going to contain ions, but it just allows the flow of electrons.
Yeah.
So like if you think of salt, it's probably not going to be like NaCl. It's going to be probably like something H2SO4, something like that, where the ions can flow. So it ionizes, so it allows the flow of electrons. I mean, we know a salt. We know a salt is, I've got ions, right? NaCl. So when you dissolve NaCl in water, it becomes Na plus and Cl minus. Much like the salt bridge just allows the flow of electrons because it has ions. So now what we can do, they want to know the EMF. So we can go down and we can look at our half reaction table. And we notice that these things have voltages. If we look at where our Ag was there, then you see that it's got plus 80. So we can actually write there, that's plus 80, plus 0.8, sorry, not 80, plus 0.8. So I'm going to just erase this one. I'm going to use yellow.
Yeah.
I'm talking about the AG. Can you see that there's this plus 80 there? So that tells us the voltage, the potential.
Yeah.
And then if we go down to where the AL is, that's minus 166. So let's write it in thing. So minus 166 was this one, and this one was plus 0.8.
Yeah.
Okay, I'm going to stay down here because there's an equation where we can see, notice that they also can give you two tables. So fluorine doesn't always necessarily going to be at the top. It could be at the bottom over here like that, but it doesn't matter. Do you notice that it's just the same thing reversed? So when you're checking things out, don't let it confuse you. Just remember whatever's closest to the fluorine gets reduced.
Yeah.
So now when we go up, there is an equation there that says E cell equals E red. E cell, you see that one there, equals E red minus E oxidation. Well, remember red is red cat, right? So we could think of that as also E cat minus E anode. And just above that, I don't know if you can see that, there is also the equation of E cell equals E cathode minus E anode. So if you forget, it doesn't matter because you can see that the reduction and the anode are interchangeable there. You see that? I'm gonna circle them in pink so you can see them.
Yeah.
So can you see that?
Yeah, I can.
And then this is an Afrikaans, but cathode minus anode. So these two, reduction, cathode, oxidation, anode. So those are basically the same equation. So they say if you want to work out the cell, just do the cathode minus the anode. Okay, so when we go now to the top, they want the EMF. So the anode and the cathode. So it's plus 0.8, right? Because that would be the cathode. So the plus 0.8.
Yeah.
So if we put that in the equation, I'm going to just actually, you don't have much space. I'm going to write it over. So do you see that it's going to be 0.80? So 0.8 minus, and then the cathode is the minus 1.66.
Yeah.
And so a minus gives us a plus. So it'll be 0.8 plus 1.66 gives us 2.46. So this answer here would be 2.46. Okay. So this was, okay, I know this wasn't an IEB paper, but it's showing the, it's basically the same kind of thing that you have to learn anyway. We'll do an IEB example as well. Now, if I look for advantage in the paper, we can just actually look for 2017. They'll probably have it. We look at the memo and just see how we did. This one. So the 2017 paper. Oh, they don't have the answers to the 2017 paper.
So good.
2017 memo, physical science. Oh, wait. Yeah, paper 2. That was question 8. Okay, so it was a voltmeter. Okay, so it was the first thing I said. Because I suppose it's measuring the voltage. So if it's just telling you the direction, it's a galvanometer, but don't worry, voltmeter is good. And then we said it was the anode, right? Because I wanted to know, let's check. The aluminium, right? See the aluminium there? And we mark the aluminium as an anode.
Yeah.
And then we go to here and we see that it is indeed the anode. Okay, here they ask for the full. I think I didn't read off the table correctly. I didn't get the AG properly. Of course, we did get the 2.46.
Yeah.
Few half reactions. When we go, and do you see how they didn't want the spectator ions, the NO3. They just wanted this one. Yeah. So they wanted this and this. Now, actually, if we go down to AL,
Yeah.
Do you see that it is 3 plus? I don't know if you can see that. I can zoom in a bit more. So there's no excuse to get it wrong. I shouldn't have got it wrong because it is there. I just read it as plus. But if we zoom in, there's the AL there, right? It's 3 plus.
Yeah.
So it's just a matter of actually such a silly mistake there. You just got to read off that says AL 3 plus. You just circle it in yellow. See that?
Yeah.
So this should have been AL plus 3 plus.
Yeah.
Plus, and then it'll be 3 electrons to balance it out. Okay. But you can see how everything I did, I actually got off the table. So I'm just going to stop recording here. This is Mackay. Okay, so you're happy with that? I think we can stop there, and I'll just stop recording there.